Hello, today we are going to look at the CMake debugger that's inside the integrated development environment Qt Creator 12. This is a KD Git repository, kconfig, KD framework. Let's open it in Qt Creator. I've started the debugger, which is this one. In the main menu of Qt Creator, debug, start CMake debugging. I put a breakpoint on the first line of the top level CMake list.txt file. It stopped at line first, and I have the buttons to step into, step over, step out, and continue. So let's go step into. So CMake minimum required doesn't have any CMake source code behind it. Set doesn't either, whereas project has a ton of CMake source code behind it. So the call stack right now looks like this. On the entry level, on the top level CMake list.txt file line 4, where the source code line is project, kconfig version, and kf version. Let's see what this kf version is. If we hover on top of the variable, it doesn't say its version, but then we can drag and drop it to the watch tool window, and we see that the version is the one defined previously on line 3. Okay, and then from here, the call stack has entered another CMake source code file, which is from the temporary build directory where CMake generates files. So this is something about my operating system. So I'm using Ubuntu 23.10, CMake system.cmake. So files that contain CMake source code have either the extension .cmake or have the file name cmakelist.txt. Maybe there's some other possibilities, but these are the big two ones. Okay, let's look at the local variables. We're going to look at CMake host system. Let's collapse the projects tree window, tool window. CMake host system. There's no such local variable yet. Step into. So there's nothing to step into set. Okay, so all of these local variables have been defined. CMake host system, CMake host system name, CMake host system version, and system processor. Step into some more. And now it declared local variables CMake underscore system, which are these. CMake cross compiling, this one false. Okay. Let's use this local variable and put it into the watch tool window. And now, besides the variable, local variable name value, we also have the type. I'm not sure why in the column type I cannot see anything in this tool window, but I can see in the watch tool window. Okay, set CMake system loaded. This is colored differently. Step into. Okay, and now we're in another file in /usr. file with extension CMake, CMake system specific initialize line 13, where it unsets all of the other platforms. Step into unset doesn't have CMake source code behind it, probably just C++ source code. Okay, then it will set this value, which is CMake system name, which is Linux. Will put it in this local variable, CMake effective system name, which is not defined yet. Now it is. Okay, this is include. Let's see what include does. Step into. So it says include from the directory platform the CMake system name, which is Linux, with an uppercase L minus initialize dot CMake file, and jump at line 1, which is what we're here. So it has unset all of those platforms, and now it's setting the platforms Linux and Unix. Okay, set CMake specific initialize loaded, and now we're in another file which is in the intermediate build directory, C compiler CMake. So these are probably values taken from my operating system. This is what CMake has found available on my operating system. And because we're inside Kit Creator, also inside of the kit, which is this thing. This thing. And this thing. Okay, back to edit. Step into. So it just defines some local variables, probably. Okay, this is probably the first logic. So not sequential structure in the CMake programming language, but a alternative structure in the CMake programming language. So if, let's see the value of CMake C size of data pointer, it's 8. So if this thing is defined, which it is, then it's going to take the value, which is 8, and put it probably as a string into this thing. So let's see what it actually does. It was a string before this 8, and now it's a string. Can we edit these values? Sure. AC compiler ABI ELF. So it's not A out. Architecture. The triplet. It's setting the same value in the triplet, which existed before. CL. Okay, so this is for the C compiler. On sets. Okay. And in here we have a repetitive structure in the CMake programming language. We have the for each. So it's three values: C objective, C objective, C++. The variable of the loop, which is long, takes all of these three values one by one at each iteration. And this is the body of the for each, which contains an if and inside another for each. Okay, and the CMake debugger will fail to run at some point. CMake process crashed. So I've put a breakpoint in the for each. Let's see if we can get to line 44 this time without having the debugger crash. Okay, press continue. F11. So let's see the values of lang. It's C, then objective C, then objective C++. F11. What is this thing? Extension. Source file extensions. And what's lang? What about with this? So it's C. So let's inspect these things. Let's see if we can make this be uppercase C, which is the current version of lang. And the possible extensions are C and M for the C programming language source code files which are not include files. Okay, so these are the possible extensions for C++ source code files which are not include headers. Remove item from list extension, so it will try to remove lowercase c from here, which there isn't such a thing. But there is a lowercase m, so let's see what that does. F10. It did shrink the list. So this is for it did the entire for each and remove the lowercase m. And now it's going to remove the extensions for Objective C++. F11. Okay, so using the debugger, we can see how the local variables are being set. We can inspect the available local variables at a given point in time when the debugger is paused. We can inspect the directories, the cache variables with their details, so the help string, type, and current value. We can step into CMake source code files. We can see what the alternative programming structure. So if does, what for each does, for repetitive structures. There's mathematical expressions, there are operations on lists, like we saw before, removal of items from a list. We have a call stack, we have a watch window, we can see how the CMake source code files are being included, like in this case, F11. So it goes to line 1, or the first non-comment, non-white space source code line in the CMake source code file for CMake generic system.cmake, which is in /usr, which then includes another file, which then puts a guard. Okay, and we're at something even more complex in the CMake source code language, in the CMake programming language, which is declarations of functions. Another function, CMake install prefix. What's the value of this thing? Watch. Cache path. What's cache path? Not in here. Okay, next. CMake install default component name, mark as advanced. And now we're out of the include file. So this is the value, the right hand side. This is the variable name, the left hand side. This is an assignment declaration. Include. F11. So this is platform/Linux in /usr. And it crashed again. Let's start the debugger one more time. F5. So the shortcuts are continue F5, step over F10, step into F11, step out, shift F11. Let's remove the breakpoints, F5. There's no more breakpoints. Back to CMake list.txt. Let's see this add subdirectory. Let's see this ECM set disabled. Options. Start debugging. F5. So build QCH is off in my case. This is for off. So this is a string with a value off. Okay, and QCH is off also. No, it's empty. Okay, config version header. ECM setup version F11. So this is a function defined in the KD Git repository ECM extra CMake modules, which is installed using kdsrc-build in ~kd/usr. This is no arch cross-platform CMake programming language source code, which defines the function. CMake parse arguments F11. So CMake parse arguments, I'm going to guess, is implemented in C++. CMake policy, what this thing is. Implemented in C++ probably. Just local variables. Let's see what type this one is. It's still string and it's not on off, it's true. String regex replace. What is this one? Let's see the value. So it's version 5. And the regex expression does any number of zeros, could be 0 of zeros. So there's 0 of zeros, there's just a 5. And then 0 to 1, which is 1, any number of digits but at least 1, which is 5. And that's considered a regex, what was that, result group thing with round parentheses. And then replace with \1. Does that? Defined. If not defined, ESV so version. So ESV so version is a local variable type string version 6. So it's defined. Okay, interesting. Are there local variables of type which is not string? There appeared this thing, which is the CMake tests, ctest. Some of the targets. And as the debugger is running, the build directory keeps getting populated with more and more files generated by CMake. So you could also clean up the build directory, so delete it, put a breakpoint in the top level CMake list.txt file, And then as you use the debugger to advance through the CMake source code, you see what files are generated in the build directory. So for instance, at line 4 project, it's going to generate 3 directories there with some files inside. So this is ESV, this is kconfig underscore version. We're still inside extra CMake modules. ESV is probably what? ECM software name or something. Okay, so let's get out of ECM. Start the debugger again. Maybe the DAP debug adapter protocol server inside CMake has a timeout or something because the debugger crashes at random positions in the CMake source code while I'm debugging. Okay, ECM set disable deprecated versions. What does this thing do? F11. So it's a function defined in ECM. Math. Let's see. Is even number 0. This thing is cute and 6.5. Pair count 2. Okay, so this is similar to a assignment to the variable number pairs of this right hand side as a mathematical expression. Because pair count is a string. Okay, for each range. So the CMake programming language has many features. Many, including range. List get. Current index 0, next index 1. String equality comparison. So cute is equal to cute. So now is cute deprecation is 1 string. So string equality returns 1 if the two values are equal. Is a cute deprecation? Yes, it is. This thing is 6.5. Add definitions. What does this thing do? It's implemented in C++. So it sets the probably the G++ command line parameter minus uppercase D, qt minus disable minus deprecated underscores. So qt underscore disable underscore deprecated underscore before. And the version is this one, 394.496. What else does it set? Add subdirectory is from so add subdirectory is like a larger include. It finds that directory and finds a top level whatever in that subdirectory file named CMake list.txt, and from there starts executing starting from the first source code line that's not a comma, not a white space. So this one adds another subdirectory, and this adds a library. So where I cannot step into, I'm going to guess that there's no CMake source code behind it. So CMake source code in my case is available in /usr because I have installed CMake using the packages from Ubuntu. And then there's CMake source code in tilde/kd/usr because that's where I have installed extra CMake modules using kdsrc-build qt6. And then other CMake source code files reside inside of the build directory, which is this guy, tilde/kd/build/kconfig. And probably all of these source code lines that you cannot step into are actually part of the C+ or of the CMake programming language syntax. So let's see that for target sources. CMake, Control V. Okay, so target underscore sources. And then target, in our case, is kf6 config core. And then one of these three, in this case, it's private. And a list of items. In this case, it's these 12 items, or how many they are. And then we close the round parentheses. All of these other things are optional because they're enclosed in square parentheses. Okay, when we see ECM prefix, that's probably some function declared inside the ECM KD Git repository. And it is. It's a function. Let's exercise stepping out. And it stepped out correctly, so it exited the declaration of this function and went to the next non-white space non-comment line, which is line 35. Configure file. What does this thing do? F11. It doesn't do anything, so I'm guessing it's part of the CMake programming language. And it is. It's a command. Configure file. Round parentheses. Input and an output. And that's the entire syntax. That's mandatory. The rest is optional. And that's the only thing that we have. So we have an input and an output. And CMake current binary dir is the inside of the build directory. Okay, another function from ECM. Target compile definitions F11. Let's see what this thing does. It's a CMake command. Target compile definitions. A target KF6 config core. And then one of these three, and it's private. And then a list. And in this list we have just one item. A conf update install location. Not a directory. Kconf up. Not visible in the cache. In the cache variables. So I'm not sure what this thing is. Kconf update install location. What is it? Specifies compile definitions to use when compiling a given target. So compiler definition, that means I don't know, a G++ command line parameter. Okay, directories to include F11. Test target, which is KF6 config core, and then optional system, optional after before. None of these are provided. And then mandatory one of the three, which is interface. Interface public and private. Okay, and this is a multiple value thing. So it goes into include /kf6 /kconfig and into include /kf6 /kconfig core. Okay, target link libraries. So this is probably the G++ minus lowercase, I know, L library, which says that it depends on the Qt6 library for Qt6 core. And if we're using dbus, and we are, then also depends on Qt6 dbus, the library file when linking. Okay, we saw list get, list set, list remove, and this is list append. So it's a list because it's separated by semicolons. Let's copy this thing. Whoa, what is this? So this CMake variable keyconfig core headers contains many include files. So C++ include files with full path separated with semicolon. This list does not contain keyconfig version check mine_p.h. And in here we see the operation list append, which will actually add this full path to this .h file. So let's step over. And now let's look at the new value of the variable keyconfig core headers. This guy. And the after keyconfig watcher.h, which was the last item in the list previously, now there's also a semicolon and the keyconfig version check _p.h file added to the list. Okay, now let's see how we actually got to have Qt Creator 12 be able to debug correctly a CMake list.txt file. First of all, we have this blog post where Qt Creator 12 is released, where it says CMake debugging and profiling in CMake 3.27, and later there's built-in debug adapter protocol. So this is one of the two protocols for from Microsoft for Visual Studio Code. The other is the language server protocol, and this one is the debug adapter protocol, DAP. The other one is LSP. So CMake contains a debug adapter protocol inside if CMake is at least version 3.27. So let's find out the version of CMake. CMake exists where and at what version. So it's 3.27.4, which is greater than 3.27. Okay. And we'll need Qt Creator, the integrated development environment version 12.0 at least. For that, we're going to use the Qt online installer, that from qt.io. Sure, where download, try this one. Download open source. And somewhere is the installer. Looking for Qt binaries, Qt online installer, Linux, this thing. After you run the online installer and install some software there, among others, this Qt online installer will also install on your computer the Qt maintenance tool, which is this one. You just open the start menu in your Linux operating system. In my case, it's the KDE Plasma startup menu. And in here is available as Qt maintenance tool. In order to use the Qt Online installer, you will need to create an online account on qt.io, the official website of the Qt framework. And let's see how it's made available as Qt developer and design tools. and the latest version of Qt Creator. In this case, it's 12.0.1, which is very recent from yesterday. Okay. And then in my case, I am using the KDE build framework named KDSRC-build. So that's using this build framework, I can build KDE Git repositories such as this one, kconfig. So let's do that. And the name of the Git repository, which is this thing. Okay, kconfig depends on extra CMake modules, which is another KDE Git repository. We have seen while debugging and stepping into the CMake source code file from the KDE Git repository kconfig that it actually depends on CMake source code files, which are part of the extra CMake modules ECM KDE Git repository. Okay, and now we can use the instructions that we have while programming for KDE on how to load this KDE Git repository kconfig, which was just built using KDSRC-build, how we can load it into the integrated development environment Qt Creator. Get involved, development, and in here it says configure the integrated development environment, and the top one is Qt Creator, which is the best suited for programming for the Qt using the Qt framework or programming for the KDE community. Okay, so again, we have installed Qt Creator from the online website. We have built a KDE Git repository using KDSRC-build, not kcalc in this case, but kconfig. And now we're going to follow all of these steps from here. So we start Qt Creator. We close all of the projects which they have been already closed. No need to do that. So close all projects and editors. Open, where are you? Open file or project. And then when we build kconfig, we had two directories, tilde/kd/src/kconfig. This is the directory where we KDSRC-build has git cloned the Git repository, and tilde/kd/build, not src kconfig, where the build took place. So CMake has generated a ton of files in here. Then Qt has generated some files. Then using Ninja, the binaries, the build artifacts were created, and then using Ninja, the binary artifacts were copied from here into tilde/kd/usr directory. So to the integrated development environment Qt Creator, we need to specify the top level CMake lists file from the Git repository. And then we need to specify this directory, the build directory. In here, so we go projects, manage kits. It looks okay. Import existing build, Control V. So the directory with build. Choose. Another debug build configuration has been created because we did what it says in here, which is to make sure that the CMake build configuration is set to debug, not rel with debinfo in the KDSRC-build frameworks configuration file. Okay, and at this moment we just opened a CMakeList.txt file from here, and then we just imported an existing build, which is in the tilde/kd/build/kconfig directory, There's additional configurations that we can make to this project, but nothing is required for the next thing, which is just to make sure that CMake configure is successful. So let's test the CMake configure is successful. That was already run automatically by the integrated development environment, but let's make sure it works correctly. So in the Qt Creator main menu, build, and then run CMake. It's successful, does not find any missing features or packages. At this point, we can start debugging the CMake source code. We go edit, and then this button to show left sidebar, Alt 0. We can look either at projects or at the file system. The top level CMake list.txt, I put a breakpoint on the first line. This is always a good idea to, no matter where you put your breakpoints, also additionally put a breakpoint at the very entry point where you could, at the very first point that you can put a breakpoint, put one, because that will eliminate all sorts of issues where you're still waiting for the debugger to stop at line 61, but then the debugger didn't even enter this file at all. Okay, so let's say I want to actually debug line 61, and I still have put a breakpoint on the very first line, on the very first CMake source code file that's being used by CMake. Okay, so it should stop at line 1 first, and then I'll jump straight to line 61. Using F5, go to the next breakpoint. So we don't start the debugger like this, because that would build the current project, create the build artifacts, and then choose one of the build artifacts, which in this case is debug sanitizer text, and then run that executable. We don't want to do that. We want to do this step, build run CMake, and only this, nothing else, but inside of a debugger. So as it's documented, where? So these are the release notes, whatever the blog post that announces Qt Creator 12.0. And then there's this chapter CMake debugging, which is actually a symlink, a URL. So I'm navigating to that URL. And this is the entire documentation about debugging CMake project files. It says, find a CMake file, which I did. Put breakpoints, which I did. One on line 1, another on line 61. Which you can do by just clicking at the left of the column with line numbers. Okay. And then it says from the Qt Creator main menu, debug, start debugging, start CMake debugging. And that's it. It has stopped on the first possible line. When the application stops at the breakpoint, so when the execution is paused, like it is right now, you can examine data in the debug mode views. So that would be the watch tool window, which is this rectangle, and the local variables, etc. view tool window in the top right hand side, right hand corner. Okay. I can delete all of the names inside of the watch tool window, Ctrl A, and then press the delete key. I can go to the next line either by stepping over, stepping into, stepping out, or continue until the next breakpoint. The same options are available also from the Integrated Development Environment's main menu. So continue F5, stop debugger, F10 step over, F11 step into, Shift F11 step out. And breakpoint is F9. So I'm going to go continue F5. It goes to line 61. The same thing, F5 continue to the next breakpoint, and to each step I'm going to look at the list of breakpoints, which is this tool window. I can see that these are the only 4 breakpoints. I can delete all of these breakpoints, Ctrl A, and then press the delete. Put back the 2 breakpoints that I wanted, line 61 and line 1. Okay, F11 to step into, which means if possible, if there's CMake source code behind line 70, go to that CMake source code. And there is a ton because add subdirectory will find if there's a subdirectory src in the top level git clone directory, which there is, and it will find in there a top level CMake list.txt file in the subdirectory src, finds one, and then starts evaluating the entire file. So F11 actually goes into this file at line 1. And then inside the subdirectory src, the CMake command add underscore subdirectory searches for a core subdirectory, which it finds. Is there a CMake list.txt file there? Yes, it is. So it will go here, F11, step into, and then there's no more subdirectories here. And this core directory actually defines a library, kconfig core, add library. Okay, so this is it, coupled with you actually learning CMake using the official CMake documentation and also reading CMake source code file written by other people. In the KDE community, most of the KDE Git repositories have which use the C++ programming language, and the Qt framework will probably use CMake. So do open some of these KDE Git repositories, look at all of the CMake source code file in there, and learn some of the tricks. And for more advanced use cases, when you want to know exactly what, lines 79 to 81 do, there's always the possibility of doing print debugging, so you can list the content of the kconfig core headers before line 79 and after line 81 to see how its value has changed. Or you can use the CMake debugger, for example, inside the Qt Creator integrated development environment. Okay. We can do the same thing as printing the kconfig core headers content before line 79 by looking at the value inside of the watch tool window in Qt Creator right now, and then advance to line 81, and the value stored inside this variable will be different. So that's it. The CMake DAP, debug adapter protocol debugger, is an important tool. This is how you use it from Qt Creator. Thank you.